Hi students, today we are going to solve one organic question. Whenever seeing this type of this type of structural question in organic chemistry, you will get fear, right? Okay, let us solve this one. This will be a easy one. After solving this one, you can feel that. Okay, look at this. Here they have given one alcohol. In that, so far by saying that itself, that is there are in our 11th and 12th there are seven categories of compound. One is alkyl alcohol, aryl alcohol, alkyl halide, aryl halide, and then aldehyde ketones, carboxylic acid, and then amines, right? So here that alkyl alcohol is given here. How we are saying that alkyl alcohol, OH group is attached to that alkyl part. If it is an aryl part, there should be a delocalization in that ring. So if the OH is attached to that aryl part, then it will be aryl alcohol. If it is attached with the alkyl part, that will be alkyl alcohol. So alkyl alcohol will give only two types of reaction. One is nucleophilic substitution. Based on the reagent, we will have two types of reaction, nucleophilic substitution, and another one will be beta elimination. But the aryl alcohol will only give electrophilic substitution. That we will see in some other video. Electrophilic substitution only will be there in the case of aryl alcohol, and that electrophilic substitution also there are some complications. That is, OH group will not involved in that electrophilic substitution. Only the H plus at the ortho or para position will be released as a electrophile, and another electrophile will be substituted in the case of aryl alcohol. But here they have given only alkyl alcohol. In that one, there are two possibilities, nucleophilic substitution and beta elimination based on the reagents. Here, look at this, they are heating that alcohol in the presence of acid. That is why it will be a beta elimination. What is the meaning for beta elimination in alcohol? The alpha carbon which is having that OH and that beta carbon which is having hydrogen will be participated in this reaction. First OH will be removed, and then we will get that carbocation at this part, and then the beta hydrogen which is next to that alpha carbon. So if there are more than one beta hydrogen, what you will do? More than one beta hydrogen, then you should select the carbon which is having less number of hydrogen. So here the less number of hydrogen is there. I am assuming like that. So less number of hydrogen will be removed, and then due to that removal, the valency will be satisfied by forming a double bond at this position. So this is called beta elimination. But here how the beta elimination is working, let us see that. So beta elimination is there. What are the possible products? First, I will tell you. So without writing the mechanism, if you are writing that equation, then you will get the wrong product. Let us check that. So what they have given, one cyclo butane ring which is attached with the uh, this one, that is cyclopropane ring, and then another one cyclobutane with alcohol at the joining position, right? So first OH, if you are writing the products without the mechanism, you may wrongly assume that here, look at this, there are two beta hydrogen, right? Here there will be two hydrogens, and here also there will be two hydrogen. Whatever may be, whenever you are removing this hydrogen or this hydrogen, you will get the same alkene. That is why not necessary to bother about that, right? Because both the beta carbon is having same number of hydrogen, not necessary to apply that same step rule. So we are going to give the product without giving carbocation mechanism. Without writing carbocation mechanism, we are directly giving the product. So this will be the possible product we are expecting, but we will see what will actually happen. First carbocation will be formed by after the removal of OH minus. So this OH minus will be removed first. So I'm going to remove that OH minus. So how it will form? That is the carbocation. Which carbocation will be formed? So whenever the carbocation is present at the ring, it will be highly unstable because carbocation carbon need 120 degree, because carbocation carbon will be sp2 hybridized. So sp2 hybridized need 120 degree, not like a single bond. If that is sp3 hybridization, if all the bonds are single, then it will be 109 degree. But here we need 120 degree bond angle. But in that ring, if the carbocation is present there, what will happen? Only 90 degree is there. So the repulsion will be more, the carbocation will be less stable, so it will rearrange itself to form the more stable carbocation. Two possible rearrangements are there. Let us see one possible rearrangement. So I am going to join this carbon atom here. So if you are joining this carbon atom here, what will happen? This carbocation will go to will choose this carbon, right? Because this bond has been broken. Look at this. This bond will be broken, and the broken carbon atom will link here. But here, this broken atom is not at all having any linkage. That is why the plus charge will be shifted at this position. So what is happening here? I'm writing this one, the plus charge. Okay, I'm again doing this mistake here because that carbon is linked with here. This carbon is linked with this one. So the cyclobutane ring will be as such, and this plus charge will be here now, and then cyclopropane part is there. So now somewhat stable carbocation has been formed. Here the angle is not at all 90 degrees, so somewhat stable carbocation formed here. After that, the removal of beta hydrogen. You can think like that. Here the beta hydrogen will be only one, and here the beta hydrogens are two. According to Say's rule, we have to remove this hydrogen. But if you are removing this hydrogen, ring strength will be more. So the double bond will be there at this position, then the ring strain will be more because there is only 60 degree, right? So in that the angle will be 60 degree. If you are removing this again, I am going to do two more possibilities here. So one possibility will be like this, right? The double bond will be formed here. We have to give which will be the more stable one. So another possibility, this will be against the Seystack rule. Another possibility for this one will be double bond like this, right? But look at this here, there is only 60 degree. The cyclopropane ring, there will be only 60 degree, right? So 60 degree means it will be less stable one. So because the double bond is also sp2 hybridized, then we need 120 degree, right? So 120 degree, almost half the angle. So it is not a stable one. This will be the stable product. And another more possibility is there. Let us check that one. Now I am going to show you the another possibility. Again, the same carbocation has been formed here. Another possibility. So let us see all the possible products. It will be easy for you to understand the concept. That is why I'm showing all the possible products. Actually, we have found the answer, but anyway, I will give you another one possible product and I will give the exact thing why we are selecting that as a stable product. Look at this here, the carbocation formed will be like that. In the previous case, we have rearranged the carbon here, right? So we have rearranged this carbon and we have linked this here. But now I am going to link which one? Wait, I will take that. Yeah, I'm going to link this carbon atom. So there's no more possibilities will be there, right? So we have to remove that plus charge at the ring joining position, right? That is why this may also be the possibility. So this bond will be broken and here the linkage will be formed like this. Look at this. Once again, I'm showing another one possible product. This ring will be as such, but the cyclopropane ring is detached here. And look at this. One carbon is there and another carbon. This carbon is now linked with the cyclobutyl part. And then this carbon is already having a link here. Now the plus charge has been shifted. Okay, wait a moment. Now the plus charge, this carbon is linked here, but the plus charge will be shifted at this position, right? So that is the plus charge will be, this carbon is linked here, the bond will be broken. That is why this carbon will have now the plus charge. That is the plus charge will be shifted here. You have to do that again and again, then only it will be easy for you. Then concept clarity will be there in the case of carbocation, ring strain and everything. This one question will give all concept clarity. I will tell you after finishing this one. Look at this here, the carbocation formed, the formed carbocation will be here, and then there is no hydrogen at this beta position. That is why we are going to select this beta position for the removal of hydrogen. So beta hydrogen will be released 1, 2, 3, 4, 5. So this is a 5-member ring. So for the conflict, for just simplification, I am writing the 5-member ring like that. This is a 5-member ring. So, but for while I'm doing the rearrangement, I'm just showing that how the rearranged uh, bond has been formed like this. So now I'm going to represent that in a simple way. So the attached position, the next position with the attached position is having the positive charge, and then 1, 2, third position, 1, yes, 1, 2, 1, 2, third position is now having another one, cyclobutane ring. Cyclobutane ring is there, right? So cyclobutyl ring is there. Now the beta position, which will give the beta elimination here. So the beta position is, there are two beta position, this one and this one. Here only beta hydrogens are there. That is why I'm going to remove that beta hydrogen and we are going to form the bond here like this. This ring is highly unstable. Why? There are two bridgehead positions. Bridgehead position will give less stability. That is why this one is one bridgehead position and this one is another one bridgehead position. But in this case of the more stable one, we are getting the bridgehead position. That is only one bridgehead position is there. That is why we have to select this one as a more stable one. This one will be the more stable. Other actually cyclobutane will show a lesser strain than cyclopropane. So we may expect this one, but because of that bridgehead position and stability, we are selecting this product, this one. So the product will be what is the product here? Yes, we will get to this one, right? So C will be the answer. And look at this here. I have shown some Bayes theory. Why I am showing this one? To show the stability of that cyclobutane and cyclopropane. Cyclobutane is having the 19-degree repulsion. Cyclopropane is having 49-degree repulsion. That is 49 degree. Whenever the degree that is actually the carbon should exhibit 109 degree because there is no double bond, right? But here, because of that ring formation, there is only 60 degree in cyclopropane and there is only 90 degree in cyclobutane. That is why the strain will be more in cyclopropane. Even though we are getting the cyclobutane ring in the second product, we should not select this one because of the bridgehead position. So we are having the concept clarity in bridgehead position, and then ring strain, and then carbocation stability, and then rearrangement in that question. So it will be a difficult one, I know that. You please revise it again and again. You please see that video again and again. You please do with your own way. Whenever you are trying with your own way, you will get more doubts. Again, you please see the video. And if you are not getting any clarity there or any clarity at that particular part, you please send the message to my WhatsApp number, or you please post a comment. I will definitely answer your doubt. Thank you.